Recording has started.
So for the first problem here, this is really divided up into three shapes. We have a rectangle down here, another rectangle up here, and then we have this corner piece that we'll look at in a little bit. So for piece number one, that rectangle is 8 inches by 16 inches, or 128 square inches. Piece number two, that rectangle is 8 inches by 12 inches, or 96 square inches. Now for that corner piece. To do that corner piece, we have to draw it in like this to make it a complete quarter circle. The difference between here and here, let me change colors here so you can see a little better. This length is the difference between 24 and 12, which is 12 inches. This length over here is the same. The difference between 28 and 16 is also 12 inches. So that assures us that this is a complete quarter circle. So the area of that quarter circle in green is pi times 12 squared. But it's a quarter circle, so I have to divide by 4. So I'm just going to use 3.14 times 12 squared and then divided by 4 because it's only a fourth of a circle. We get 113.04 square inches. However, this little piece here is missing. So I have to subtract that back out. Well, this is 8 inches from here to here. If it's 12 the whole way, that has to be 4 inches. So that area is pi times 4 squared would be the full circle, divided by 4 to make it a fourth of a circle, a quarter circle. Pi times 4 squared divided by 4 is 12.56 square inches. So now we need to subtract those. We're going to get 100.48 square inches. So that gets added. That's our piece 3 here that gets added up here. Giving us a total 324.48 square inches of area for that shape. How many of you had that correct? Nobody? Any questions on how I got there or what I did with that you want me to go back over?
I tried doing the top of it instead of the corner of it.
Gotcha. Yeah, that corner is a tough thing to do because of the way it's sitting there. Especially when we're working with circles, we often run into things where we have to fill in pieces and then subtract them back out. And that's one of them. That's really the only way to go about that. There is one other way that you could go about it, and that's to use the average radius. So or average, I should say, circumference. You off of the average radius. But that purple line there, actually let me switch it to red so you can see it better. Finding the length of that red line. Well, this is 4 here. Out of 8, this would be another 4 and 4 if I split that 8 in 2. So the radius of that red line would be 8 inches. Which means the diameter for that red line would be 16 inches. So I could find the circumference of that circle, which would be pi times 16, of course, then divided by 4 because it's only a quarter circle. Which gives me 12.56 square inches for that. That's the length of this. That has a width from here to here of 8 inches. I could multiply that by 8. 12.56 times 8 actually does give us the 100.48 that we came with up here. So there are a couple of ways you could do it. To me, the way I just did it here doesn't make a whole lot of sense because you're using that average basically what you're doing is you're treating it as a rectangle that's been bent. It just doesn't make as much sense as a quarter circle with another smaller quarter circle missing out of it. The second one over here, finding the surface area. Do you guys, anybody want an extra couple minutes try to finish that one up? Okay, let's go over then. So we talked about cylinders yesterday and the surface area of cylinders. This one is a big cylinder with a hole cut out of it, a hole right down the middle of it. Basically, it's a bushing is what it turns out to be. So what we're going to do is we're going to look at the surface area of the outer cylinder first. On the outside there, we have that circle. It's pi times 8 squared. Remember, 8 is the radius. If our diameter is 16, 8 is going to be the radius of that circle. So pi times 8 squared is about 200.992 square inches. 0.96, sorry. Square inches. There's two of them. There's one on the other end. Then on the outside, the lateral surface, remember we talked about that being a piece of paper rolled up. And you just cut it down the side and unroll it to get a rectangle. Well, that rectangle is going to be 30 inches in height. The width is the perimeter, the circumference of that big circle. That circumference is going to be pi times 16, or 50.24 inches. So that area, that lateral surface, is 50.24 times 30, otherwise known as 1,507.2, right? Square inches. So if we add all those up, we got 192, 212, 90, 1909.12.12, 1909.12.
For some reason, I got 1507 for that second measurement, or that second one, but I got 0.965.
0.96, yeah, I just rounded it. You used the pi key, and I used the 3.14 is all.
Okay.
That's the only difference there. So yeah, we're around 1909, 1910, somewhere in there for that outer surface area. Now, the inner surface area. We got to figure out what parts are added and what parts are subtracted. The circles are subtracted. If that's 4 inches on each side, the diameter of that little circle is 8 inches, which means it has a radius of 4 inches. That's pi times 4 squared, which is 50.24. But we have to subtract that. In fact, we have to subtract that twice because there's one on the other end that's also cut out. So 1909.12. Again, if your decimal's a little off, that's fine. Minus the 100.48, that's the 250.24s, is 1818.64. Now the lateral area of that smaller cylinder, the sleeve in here basically in our bushing, that actually has to be added. That is exposed area, excuse me, that is exposed surface area that is there. We need to figure that out. So that is a circle with a diameter of 8, so a circumference of pi times 8, which would be 25.12, times that length of 30 inches. So I have 25.12 inches times 30 inches, which is going to give us, what, 753.6 square inches, and that has to be added in. So I'm getting 2,572.24. You might have had 2,573 if you used the pi key instead of 3.14. If you're within 2 square inches of that, I would count you as correct. So that's another thing you have to look at when you get to these more complex shapes, like this bushing here, is when you're finding areas or surface areas, what pieces do you have to add in, like the inner sleeve, and what pieces do you have to subtract out, like the smaller circles on each end. So this part of the course, the next few weeks, is going to stretch your visual ability a little bit. That's part of the purpose. We found that's one of the things that, with the video age, with being able to put things on a computer screen or whatever, that visual ability, that ability to break things down visually, is something that's not as strong of a skill as we used to see, because people don't have to do it anymore. It's on the video screen for you. You don't have to visualize it and manipulate it in your mind. But when it comes to dealing with blueprints and dealing with cutting a shape, that ability to visualize it and rotate it and see other perspectives of it is a really useful skill to have. So we're going to do what we can to develop it for you here. Remember, there is a quiz from yesterday that is due by noon today. So if you haven't done that, I noticed a few of you have submitted it already. That's great. If you haven't done that, make sure you get that done. Anybody have any questions off the homework from yesterday or anything we talked about yesterday? Okay. So we're going to move on to the next step today. I had mentioned yesterday there's that packet out there that's posted in Blackboard. Your homework for the next several days, several classes, is going to be out of that packet. So either if you can have it printed off so you have it available, or if you have a laptop or whatever so you can work on the screen if I give you homework time, that would be wonderful. We don't get with this format, we don't seem to get a whole lot of homework time at the end of class anyway. But just make sure you're able to get it. If you do print it off, that homework packet, the parts that we are going to do are in the grayed boxes. So if you just print off the pages that have the grayed boxes in them, that's all you really need for homework. The rest of the packets, the pages of the packet, are explanations. And like I said, don't go past, I believe it's page 177 for now. The pages after that are coming up later in the course. And there are some of the pages after that are specifically for the Woods group and not for you guys. Okay, so today we're going to move on with area, perimeter, geometry, all that good stuff. But we're going to focus on triangles for a while. And what we've looked at so far has been right triangles or triangles where we have a known height. And I do want to focus for a little bit here today on right triangles again, because there is a relationship of right triangles. It's very important. Machining and a lot of other applications. So if I have a right triangle, First of all, of course, this little box in the corner is a square. That's indicating a square corner or the right angle of that triangle. Excuse me. The two sides of that triangle that make the right angle are called legs. I always tell students that the legs make the L, they make the right angle. The other side, the side that is across from the right angle, or the side that does not touch the right angle, is called the hypotenuse. The hypotenuse is always the longest side. Well, when we label a right triangle, we tend to label the legs with the letters A and B, and the hypotenuse with the letter C. And there's a relationship that all of you have heard of before. You don't need to remember this word, but it's called the Pythagorean theorem or Pythagorean relationship. And that is when you are comparing the legs of a triangle to the hypotenuse, the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. What does that mean? Well, let's look at this triangle here. Let's say we've got 6 inches, 8 inches, and 10 inches. That is a right triangle, I will tell you that up front. The 6 and the 8 are our legs, so I'll call one of them A, the other one B. Doesn't matter which is which. The 10 is across from the right angle. That has to be the hypotenuse, so I'm going to call that C. So A squared, that's 6 squared, plus B squared will be 8 squared, has to equal C squared, or 10 squared. Well, 6 squared is 36. 8 squared is 64. 10 squared is 100. And 36 plus 64 is 100. We get the same on both sides. So it just proves to us that, yes, that is a right triangle because the sum of the legs squared, plus, the sum of the squared legs plus is equal to the sum of the, or equal to the hypotenuse squared. Boy, I messed that up. The sum of the squared lengths of the legs is equal to the squared length of the hypotenuse. So we can use this for a couple of things. One is we can test to see if a triangle is a right triangle. So if I look at this triangle here, I don't know if that is a right triangle yet. However, remember that if it is a right triangle, the hypotenuse is always the longest side. So if there is a hypotenuse, it would have to be the 17 in this case. That would be our side C. So the other two sides are going to be A and B. And remember, it's A squared plus B squared equals C squared. So A is going to be 6 squared. B will be 15 squared. C is going to be 17 squared. Now it's just doing the math to see if they equal out. 6 squared is 36. 15 squared is 225. That adds up to, what is that, 261? 17 squared is 289. Those are not the same. This is not a right triangle. The other thing we can use it for is we can use it, if we know it's a right triangle, we can use it to find a missing side. Probably the simplest one is if we know the two legs and we're trying to find the hypotenuse. So again, this is A and B, and my hypotenuse is going to be side C. And the formula is A squared plus B squared equals C squared. Well, A is 8, so that's 8 squared. B is 15, so that's 15 squared, equals C is X, so that'll be X squared. 8 squared is 64. 15 squared is 225. Nothing for us to do with the X squared quite yet. 64 and 225 is 289 equals X squared. We're going to solve that by taking the square root. Square root of 289 is 17. The square root of X squared is just X. So this is 17 inches for that hypotenuse. It's a little bit trickier, but we can use it to find one of the legs as well. So if I know that one leg is 12 inches, I'm going to call X leg A, the 12 leg B, and the hypotenuse is 13 inches. I'll call that C. Once again, A squared plus B squared equals C squared. Let's fill in what we have. Well, A, the first leg is X. That's X squared. B is 12, so that'll be 12 squared. And C is 13, so that'd be 13 squared. So nothing we can do with the X squared. 12 squared is 144. And 13 squared is 169. Now to figure out X, we haven't done algebra yet, but we're going to jump ahead to a little basic algebra here. We're going to subtract the 144 to get X squared equals 25. Then we're going to square root to get rid of the X squared. Square root of 25 is 5. That side, that leg has to be 5 inches. Knowing how these right triangles are laid out now, if I tell you that leg A is 9 millimeters, and the hypotenuse is 41 millimeters, find the area of this triangle. Well, if I look at this, I'll draw this leg as 9 millimeters. That was A. B, I don't know yet. And C is my hypotenuse. That's 41 millimeters. I need to find side B, leg B. Because to find an area, I have to use the two dimensions that are perpendicular. Those two dimensions are going to be the legs, sides A and B. So I have A squared plus B squared equals C squared. I fill in 9 for A, so 9 squared plus, I'm just going to leave that as B squared for now because we have to find it, equals 41 squared. 9 squared is 81. B squared is going to stay just B squared for now. 41 squared is 1,681. To solve for B, we got to subtract 81 from both sides. B squared is 1,600. Then we'll square root to get rid of the squared. B equals 40. So B is 40. The units we've been using there is millimeters. So the area It's A times B divided by 2, base times height. So 40 millimeters times 9 millimeters divided by 2 because it's half of a rectangle. It's 180 millimeters squared. So now the big question comes in is, what if it's not a right triangle? What if we don't know a base and a height? What if all we know is the 3 sides? Let's say that I have 3-inch, 4-inch, and 5-inch sides. Find the area of a triangle from the 3 sides. We use something called, it's often referred to as Hero's formula. It was found by a Greek mathematician named Hieron. You sometimes see it Hero's formula, other times you see it as Hieron's formula. That can be used for finding the area of a triangle if we don't have a base and a height. We find the area in the triangle just from the 3 sides. And what Hieron found is you find the perimeter of that triangle. Just add the 3 sides up. In this case, that is 12 inches. Then Hieron defines something called the semi-perimeter, which Hieron labeled S, which is just the perimeter divided by 2. So 12 inches divided by 2 is going to be 6 inches for the semi-perimeter. And what Hieron found then is the area of the triangle can be found using a somewhat ugly formula. It's the square root of that semi-perimeter times the semi-perimeter minus side A, which is the shortest side, times the semi-perimeter minus side B, which is the second longest side, times the semi-perimeter minus side C, which would be the longest side. So for this triangle, that'd be 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. So that would be the square root of 6 times 3 times 2 times 1. I did the subtractions in my head there. We get 6 is the area. Now the reason that came out to be a nice even number, like 6 instead of a weird decimal, is because this triangle actually is a right triangle. There's a right angle there. I could have found that area 3 inches times 4 inches divided by 2 would have been 6 square inches. That's the only reason it came out nice and neat like that. Otherwise, it will be a really ugly decimal. Let me show you. So let's say we have 10 inches, 12 inches, and 15 inches. Actually, I'm going to make that 16 inches just to avoid working with decimals for right now. So our perimeter (10 plus 12 is 22, plus 16 is 38 inches. Our semi-perimeter, 38 inches over 2, or 19 inches. So our area will be 19 times 19 minus 10 times 19 minus 12 times 19 minus 16. Now to make this easier to enter in the calculator, I'm just going to do these subtractions quick. That's 9, 7, and 3. So the square root of 19 times 9 times 7 times 3 is 59.92. Inches squared. What do you think? Kind of a handy little tool? Not the most fun formula to use, I'll give you that. But there are a lot of times where we cannot be sure, or we don't quite have a right triangle. So we need some mechanism for finding the area of that triangle. So your homework is out of that packet that is posted for September 23rd. It will be pages 144 through 147. Again, those pages are in like a gray box. The background is actually gray, and I apologize for that. That's the way that book did it. The book I stole those from did it. It makes it really hard to read in a scanned copy, unfortunately. So if there's any issues with it, let me know, and I'll see if I can get a clearer copy for you. With that, I'll let you guys have the last 11 minutes if you want to get started on that homework. If you have it available, I will be online here to answer any questions. Otherwise, I realize that many